Hello. This is the second chapter of economic statistics. So we are going to study conditional probability, which is a special type of probability. So let me compare. In the previous chapter, in the first chapter, we learned just basics, how to think of the structure of probability and like events, experiments, and intersection, union, complements, and some basic formulas like complement rule, addition rule, and like joint distribution, marginal distribution, their relationships. So we learned very basic fundamentals of probability, and it was actually too easy. So because that was just the first chapter, and in this chapter we are going to consider a different use of data, especially in the previous chapter we learned joint distribution and marginal distribution when we have multiple variables, and we manipulate the events using intersection, union, and complement. But frankly speaking, these concepts are not used in practice that much. So theoretically they are very important, but in practice what we usually think of is, like, for example, comparison across variables, right? So conditional probability is another way to utilize multiple variables and calculate a different type of probability. So let me show you. So in a chapter, you can just search for conditional probability. Any statistics textbook should have conditional probability. So let me start with an example. So we are going to use data, analyze data, to answer a research question like female police officers discriminated in promotion decisions. This is our question. We would like to study that with data. And suppose that you obtain data and the frequency table you calculated from the data is given like this. So that is, among candidates in the past some certain period, there are four types of police officers according to gender, male or female, of course, and based on their promotion decisions, you can classify them as those who are promoted and those who are not. So, and the numbers are the count for each type. So that means 288 police officers observed are male and promoted. Like that, you know how to answer this. And by the way, as you know, this is not real data. It's just fake. To answer this research question in academia, you need to do much more than this. We just use this as an example for conditional probability in this course. So it is never realistic data. So just understand it as an example, numerical example. Okay. So now let's define some notation. M stands for male, F stands for female, right? And P stands for being promoted. So promotion is given. And then we can denote those who are not promoted as P complement, P superscript C. So that means they are denied promotion. Okay? So then, first simple question. Based on chapter 1, we learned how to calculate the probability of this thing. So F cap P, or probability of the intersection of two events F and P. Calculate this probability based on the table. Okay, pause the video if you need time. I'm going to give you the answer. It's pretty simple. First thing you need to do is to calculate the total number of observations. Add four numbers, some four numbers, and then among them, we are interested in those who are female and promoted at the same time. So that means there are only 36 observations in this event. So this event includes those who satisfy two conditions at the same time, F and P, so only one type, one outcome is included in here. Then if you calculate the sample size, the total observation is 1200, and the probability of the intersection is the ratio 36 out of 1200, which is only 3%. So there are 3% promoted female police officers in our data. Now, similarly, how about this? What is the probability of promoted male police officers? Should be much easier. Okay. The answer is 288. So 288 observations fall into this event. 288 out of 1200 is this probability, which is 24%. Right? So then you may think like this. Based on the data, the probability of promoted female police officers was 3%, and that of promoted male police officers was 24%, 8 times larger than that of female. And then, do you think this is an evidence? This analysis shows that there exists discrimination against women in promotion? Just think about it. Or if you think it's not the correct, not the right way to make this comparison, think about why it is misleading. So the answer is no. The answer is no. So even though based on the probabilities are correctly calculated, but the comparison between them is not fair, because what we are doing here is we randomly choose one police officer candidates for promotion, and then just one of the randomly chosen candidate is female and promoted, or male and promoted. We are comparing those two probabilities. However, as you can see, the candidate pool size is different for male and female. So if you randomly choose one police officer out of the whole pool, population, we know that there are much more male police officers than female. So even though the probability is 8 times larger for male, but this may not be due to the promotion decision, but may due to the pool size difference across gender. Okay, so there are much more male candidates than female. So if you just randomly choose one candidate, it is pretty natural that you are going to see more male regardless of promotion decisions. Even if the promotion is fair, was the same for male and female, but just there are more male candidates. So this comparison does not say anything about the promotion decision. It cannot isolate the promotion decision in your comparison. So we have to think about different types of probability. That is something like this. So what we have to compare is not just comparing male promoted candidate versus female promoted candidate, that's not a fair comparison because the pool size is different. But you have to calculate probability of promotion if the candidate is female or male. So we are not including the gender in our comparison. It is kind of condition. Like, let me explain a little more what happens. So what we have to compare is like this. So not just choosing 1 out of 1200. What we are going to do is we are going to look at the female candidates first. Look at the female candidates. The pool size is 240. And randomly choose out of these candidates, female candidates. And then out of 240, only 36 were promoted, which is 15%. Right? Meanwhile, now if you take the pool of male candidates, there are 960, much larger pool, and given the pool, you choose one random candidate, only among male candidates. And then what you can say here is you can calculate the probability. 288 were promoted out of 960 candidates, which ratio is whose ratio is 30%. So it shows that this comparison adjusts the pool size. The denominators are different, right? So now this is a fair comparison. You have to adjust the full pool size, and then calculate and randomly choose among the given pool. Then the pool size is adjusted. That is the conditional probability. The idea is we are calculating the probability of an event A occurs when B has already occurred. So this is a condition. Given a certain condition, we are restricting our focus on the cases where the condition is satisfied. All right? So we denote this as probability of A given B, or bar B. So this is exactly what I'm doing here. In the first, when you calculate 15%, the condition is female. So I am not just randomly choosing any candidate, but I choose a random female candidate. That means if randomly chosen candidate is not female, then I'm going to ignore that. That is not in our pool. So, like restricting our pool to female candidates, and then randomly choose one only among the females. And similarly, if you restrict your pool to male, then you are going to calculate another conditional probability with a different condition, right? So in this setup, we set the condition B, which is the conditioning event. Either in our example, it is either male or female. And then the main event of interest is promotion. So we are interested in the probability of promotion, not the probability of being a man or woman. So we are using gender as just a condition, and we calculate the probability of promotion for men and women separately. That is the idea. So then let's go back and see how we do this. Like, for example, think about calculation of probability of promotion given male, right? So if you randomly choose one male candidate, what is the probability of promotion? What I'm going to do here is I will simply erase female observations. So I'm going to restrict my observations to those that satisfy the condition, right? So delete this because like they don't satisfy the condition, but only these numbers, these observations are those that satisfy the conditioning event M. And then it is simply just one variable probability. So there are only two types remain, like whether promoted or not. Then the probability of promotion is as simple as this. Just calculate the probability only using the observations satisfying the condition. That's it. Okay, then you can try this by yourself. Pretty straightforward. Now, what is the conditional probability of promotion given that a candidate is female? So it's clear this part is condition, and this is the main event we are calculating the probability for. Okay, so stop the video here and do the algebra. Okay, so let me show you the answer. Straightforward, delete M. So we only use this side, this column, and calculate probability of P. 36 out of the total number, which is 15%. That's exactly how we calculated the probability earlier in this example. Okay. So, and what I want to note here, what I want you to note here is that the order is important. So here we calculated, probability of P given M. This means M is the condition and we are calculating probability of P. But if you switch M and P, then the probability is totally different. So for example, we calculated probability of promotion among female was 15%. But let's just see what happens if you mistakenly change the notation, the order, switch the places. Then now P becomes the condition. That means we are going to use the upper row only. Delete these guys because they are not promoted. They don't satisfy the condition. We are restricting our observations to those who are promoted according to this notation. And then among them, the proportion of female is like this. Out of total number, only 36 is women. So 11%, 11.11% is the conditional probability of F given P, which is different from conditional probability of P given F. So it's very confusing, but you should clearly understand the difference between them. And it's a good example to show the different roles of different events. What's the condition? What is the main event? Okay. So then, how do we calculate this? Mathematically, so far, definition was pretty straightforward, and the formula is just how to write that down using mathematical notation. To summarize, the conditional probability of A given B is first in the denominator. The denominator only includes those that satisfy the condition. So frequency of event B. So this many observations, this is the number of observations where B happened. So that becomes the denominator. And on the numerator is the number of observations, frequency, that A happens at the same time with B. So, of course, we restricted our sample to those where B already happened, And on top of that, on top of B, A should happen at the same time. So that's in the numerator, right? So that is exactly what we are doing here, right? So I don't want you to memorize the formula. This formula is not that intuitively understood. So I want you to understand why we need conditional probability and how we can utilize that. And then if you just follow the idea why we define conditional probability, then its formula is kind of useless, right? It is just to leave a record of what you are doing. Okay, so this is this was the definition of conditional probability. So we are going to consider a few more examples in the following videos. So see you in the next one.